Hey math enthusiast, I'm here to look over some of the problems from the 10.4 additional practice on inscribed angles and inscribed polygons. So to start off, for numbers 1 through 6, they give us circle B over to the right, and they give us some given information. So let's start off and just fill all that information into our circle and see what we can solve for from there. Now, let's focus on the first thing they gave us. They told us that arc WX down here is 104. Now, I noticed that the inscribed angle Z and inscribed angle Y both open up to that intercepted arc 104. So, first thing I'm going to do is solve for angle 1 and angle 6. I know they're going to be congruent. They open up to the same arc. They're going to be half of 104. So each of these are going to be 52. Next piece of information I want to use is the 88. All right, do I have any inscribed angles that open up to this arc? It looks like this angle over here, angle X, or number 4, opens up to that arc. So I know that that angle is going to be half 88, which is going to give me 44. The other piece of information that I was given was this 26 right here. That 26 is an inscribed angle, and it opens up to this arc up top, ZY. So ZY is going to be double 26, which is going to give me 52. The other thing I noticed is that this intercepted arc, ZY, opens up to this inscribed angle, angle number 5. So I know that angle 5 is also going to be 26 degrees. So at this point, the last angle I'm looking for would be angle 3 down here. And I can see that angle 3, it's once again an inscribed angle, and it opens up to this arc, YX. So let's focus on trying to solve for YX. Well, that's the last arc I need out of the entire circle, the 360. So what I'm going to do is use 360, and I'm going to take away all the arcs I do have, the 104, the 88, and the 52. Which gives me 116. So let's clean this up. So now I know that this arc right here is 116 degrees, which tells me angle 3 is going to be half that measure, which is going to give me 58. Now I can go back to my actual questions and answer all of them. I have all my angle measures. Obviously 1 is 52, 2 is 26, 3 is 58, 4 is 44, 5 is 26, and 6 is 52. Now, for this next problem, they're talking about the measure of angle 1 and the measure of angle 2. So obviously I'm focused on this figure on the left inside my triangle. First thing I notice is that it uses a diameter, HJ, which means that we have a semicircle on the right and a semicircle on the left. Now, if this arc is 180, that means that this inscribed angle that opens up to that arc is going to be half that measure, which means that this angle is a right angle. So in my triangle, I have one angle that's 90 degrees. That means these other two angles, angle 1 and angle 2, must add up to equal 90. So what I'm going to do is take those two expressions that they give me, that 5x plus 2 and the 2x minus 3, add them up and set them equal to 90. So that's going to give me 7x minus 1 equals 91. So it looks like x equals 13. Then you're going to use a similar method to solve for y, all right, except now your right triangle is on the other side of my circle. For the next problem, I'm focused on angle 1 and angle 2 again. So in my picture, angle 1 is this inscribed angle, and angle 2 is this inscribed angle. Now it looks like both of them open up to arc DC. So that tells me that the measure of angle 1 has to be equal to the measure of angle 2. So I'm going to take the two expressions that I'm given, that 4x minus 7, and set it equal to 2x plus 11. Now we can go through and solve 2x equals 18, so in this case, x is 9. Then you're going to use a similar method to solve for y, but now the two inscribed angles you're focused on would be 4 and 3. So for the next problem, similar to the last one, I'm dealing with two inscribed angles, angle E and angle B, and both of them are opening up to arc DC. That tells me that their angle measures are going to be equal. So I'm going to have that 2x squared minus 2 equal to 10x minus 2. First thing I want to do is I notice that if I add a 2 to either side, these are just going to cancel out, which now leaves me with 2x squared equal to 10x. Well, there's no third term, there's no constant, so I'm not going to have to factor here. So what I want to try to do is get this x on the left all by itself. So I'm going to divide by 2, and I'm going to divide by x. All right, that'll leave me with just a single x on the left-hand side. But I got to divide this side by 2x, which leaves me with 5. And what they're actually asking for is the measure of angle CED. So that's this one up here, which would be 2x, which I now know is 5, minus 2. Remember your order of operations, you got to square first. All right, exponents first, then I'm going to multiply. So my final answer is 48 for that angle measure. For the last problem, it's an inscribed quadrilateral. Well, I know, according to my theorem from this section, the opposite angles are supplementary. Well, I don't have angle Q right now. Obviously, that's what they're asking for. So I'm just going to focus on angle M and angle P. I know they're supplementary, so they're going to add up to 180. So I'm going to have 4x plus 5 plus that 3x plus 7 equals 180. So I end up with 7x, 168, x is 24. Now, what they're actually asking for is Q, but before I get to angle Q, I want to focus on angle N. Well, I just solved for x. I know x is now 24. So I'm going to plug that into angle N, which is going to give me 96 minus 10, which gives me 86. Now, as I said, I know that these two angles are going to add up to 180, so the last thing I'm going to do is 180 minus that 86, which leaves me with 94 for angle Q.